Hey guys, welcome and thanks for coming. I'm Greg Sansom. I'm the head of infrastructure at Zip. We're a Sydney-based fintech disruptor. We offer fair, fast and seamless payment solutions online and in-store. We've experienced a huge amount of growth over the past few years. We're moving from being a startup into a scale-up, and we've got global ambitions, so heaps going on.
Cool. Hi, I'm Fahad. I'm a principal consultant in the microservices and container platform space over at CMD. We're a AWS certified consultancy that specializes in cloud native solutions and that are secure, scalable, and reliable.
Yeah, so over at Zip, we brought CMD in to help us build out a new infrastructure platform to help Zip scale reliably and quickly and safely.
Cool. So plan and execution.
So we had earlier in the year we had quite a few major projects which we had to get completed leading up into the Christmas peak trading period. The opportunity here was to deliver these projects before people started shopping for Christmas. If we didn't deliver on time, we'd miss the opportunity and the initiatives would lose their value. From the start of the project, we had about 8 weeks in which to deliver most of the platform. Plus a few weeks at the tail to do testing and assurance. We had 3 engineering teams chomping at the bit to start deploying to the new platform, and we had external partners ready to start integration testing, and this was before we'd even started, so we were under a heap of pressure to get things done. The delivery timeline that we're working to included development and productionizing of a number of new microservice applications, as well as what we focused on, which was the core infrastructure building out the platform, making sure it's reliable, scalable, secure, monitoring, instrumentation, alerting, all the nuts and bolts and all the goodness.
So as Greg mentioned, we had a very tight time frame to work in, and what we started doing was we started defining our infrastructure as code first. So whether that's Terraform or Kubernetes, so built that out, started from the AWS accounts, AWS platform, layering in all the best practice services like config, GuardDuty, CloudTrail, etc. Once we had all those in place, we layered Kubernetes clusters on top using K8s, and then the various components that went on top of that. And by the end of it, it was absolutely huge, as you can imagine. So that was the platform, and after that we had the same thing out in multiple environments. So going all the way from dev to prod, we had multiple environments up in a couple of weeks and being actively used. We had integration testing happening in about 8 weeks from project start, so that was quite good. And once the scaffold was in, we started fleshing out all the features that go into the platform.
Yeah, so as we were running through the project, Fahad and I were constantly talking about what we could do to streamline the delivery of this and ensure that the project was successful. Once we completed, we kind of continued that discussion and started working on a list of key steps and measures that we could implement to ensure similar success for future projects. This is what we're going to be talking about today. I'll run through those steps now. Specifically, they were spend some time laying the foundation, have a DevOps inception for every new product development project. Shared ownership of delivery between your operations people and the developers building the application. And the most important is big focus on the developer experience. Make sure that the developers can do their job easily.
Cool. So laying the foundation. Getting the foundation right is very important. It's the key to everything. So we started out picking all sorts of services that we wanted, and I'm sure we've all heard of one-way door and two-way door decisions. Sorry, I think we're getting a bit of feedback. One-way door versus two-way door decisions. When you're moving into a Kubernetes space especially, I think it pays dividends to be pragmatic about it and take a pragmatic approach. There's decisions and applications you can walk back from and replace quite easily, and then there's some that you can replace, but it takes significant amount of effort. So everybody's seen the CNCF landscape. It's quite large. by last count, there are more than 1,200 applications there. And it's a fast-moving space. So what should the criteria be to choose the right set of applications that suits your business today? And that's really it. The criteria should be what helps your business today? What helps your developers get your software into production as quickly as possible, safely, reliably? That has to be the main driving criteria behind the choice of those tooling. We basically figured out that a light and highly decoupled platform is a good platform to aim for. And that's that. Retrofitting, so avoid retrofitting where possible. Identify your heavily integrated complex services up front as quickly as you can. Things that'll take a long time to retrofit if you made the decision further down the track to implement. So for example, secrets management tooling. If you don't implement something today and you have developers start to build out on the platform and they need secrets, well, they'll just work around whatever solution you plan to put in. They'll start using AWS Secrets Manager or Parameter Store, whereas maybe you might have gone with HashiCorp Vault down the line. So avoid retrofitting as much as possible.
Yeah, so the way we avoid retrofitting, pretty simple way, make sure that all your non-functional requirements, whatever they are, built into the platform, at least as an MVP before you start coding. While you're laying the foundation, bring the developers in, but not on the critical path. Get them to start testing it and providing feedback, see what works, what doesn't work. We deliberately chose quite a large set of features which can be components within Kubernetes which can be pulled out or replaced. While it's possible to replace components, it's much easier to address it up front rather than having to rework things later in the process. As an example that we had, one other way to avoid having to retrofit things or rework later, you can use stubs. So for example, if something's not quite ready yet, put a stub somewhere so that when the service is ready and available, you can replace the stub with the actual implementation. Example we had here was SonarQube. So if you need code quality scanning, you haven't quite implemented SonarQube, put a stub in your deployment pipeline, mimicking the happy path that SonarQube produces. Once you've got SonarQube built, replace that stub with the real implementation and nothing else changes. Be careful when you're using stubs. Make sure that if you do use them, you've got a good plan to come back and replace the stubs with the real service once it becomes available. Yeah, so DevOps inception was the next item on the checklist. And make sure, while we've been busy building infrastructure, the product and development teams are busy dreaming up new features and building new products and services to make customers happy. That's really what everything is all about, so we need to get that right. So during the product delivery phase, there'll be a period of discovery and requirements gathering, usually conducted as a project inception. We've decided that it's good to have a DevOps inception for every single product development project. And this is where we sit with the developers, spend a good chunk of time with them, figure out what our non-functional requirements are, what are our must-haves, what can we negotiate on, find any pain points that developers might experience as they're trying to deploy applications into our infrastructure platform. Make sure that we address all these up front, everyone's aligned before we start actually building systems and deploying code. We also want to identify any knowledge gaps. So if your developers aren't familiar with a certain set of tooling that we've got implemented, find a way to fill that gap, give the developers the training and support they need, and find ways we can help each other.
Do an early skills assessment, essentially. What is it that your developers and your DevOps teams actually know about the alphabet soup of applications you're going to throw them into? So it's very easy to say, I want one Kubernetes, please, but do they actually know how to use it? Identify where they're lacking and try and focus your training on those specific things where they would actually add value. So for example, if you've got a very strong build and deployment pipeline, do your developers really need to know kubectl? I mean, personally, I think everybody needs to know it. It's a great tool. But if you're using a service like EKS, for example, a managed service, maybe learning about the finer points of etcd management might not be the best use of your time. Once you've identified what those knowledge gaps are, try and fill them in as quickly as possible, because if you don't, you may end up having shelfware or just really tedious workarounds that people have put in place to be able to use things that they don't quite clearly understand. Have an emphasis on knowledge sharing. So emphasize knowledge sharing as much as possible. If you've got a really cool solution, maybe using WAFs and global accelerators and load balancers and multiple ingress controllers and some really clever Route 53 routing to glue it all together, it doesn't really mean anything unless, one, it's running in production, and two, somebody else knows how to support it or extend it moving forward. So put an emphasis on knowledge sharing. Make sure you have brown bags and showcases, regular brown bags and showcases. Have people attend them and actually pay attention. And that's harder than people think. It's very difficult to have that happen. Try and incentivize people to come. Give them sneak peeks about what you're going to be talking about. Make sure you put aside time to prepare for the showcase. So maybe once a week or once every other week, just put aside half an hour, maybe 2 hours to prepare for a showcase that's decent quality. And incentivize people to come, like I said. If nothing else works, just order pizzas and drinks and everyone will be there, hopefully. Have a shared living ways of working document. So we found this really important. A ways of working document that had procedures on how you raise merge requests or how you get code into production or what your branching strategy is. Once you've got this semi-ready, throw it over to a team in your business that has a lot of time on their hands. And I'm sure there's plenty. They don't all need to be developers or ops people. Once it's with them, throw over some work and see how they go. How long does it take them to raise a PR? You don't have to accept it, but it validates that your processes work and you ensure that the knowledge that you had has been communicated effectively. Put an emphasis on a tooling decision record too. So have a tooling decision record. For example, if you're choosing a technology in the container scanning space like Artifactory X-ray, make sure you put down the constraints that you had around that and possibly the objectives and the pros and cons while you're actually choosing it, because something further down the line, something else might come along, and you need to have a really good criteria of what to assess it by. So a tooling decision record gives you that. And unless it's done while you're deploying it, it'll never get done. So we can guarantee that pretty much. Cool. So the third point here was shared ownership of delivery. Kubernetes, perhaps more so than other spaces, relies and implies and perhaps even relies on a strong DevOps focus. But how do you actually get your dev and ops teams aligned? So we found that having a shared objective was really important. How do you get software into production and running on in a scalably, reliably, and secure way? So if that focus is there, then your DevOps teams can be aligned to address it. If the focus isn't there, you could have your ops or your infra guys over-engineering a solution for a problem that your developers don't really have right now. So try and work out what those problems are. Is it a speed of deployment issue? Are they having issues with the reliability of the platform? Have they correctly identified all the risks in deployment? Once you've worked out what those issues are, address them and then move on to other things. Without this alignment, infrastructure guys do end up over-engineering solutions. Containers also naturally allow you to have a microservices architecture, but with microservices comes a lot of complexity. So have your DevOps team constantly chase up and work out whether you are utilizing one of the benefits of microservices, which is releasing often. Are you releasing multiple times a day, or are you just doing it once every couple of days? Make sure your developers have the autonomy and the confidence to actually push to production, and have the ops guys assist them with all hands if necessary.
Yes, this is...
Sorry. The other thing you can, the other way the alignment happens naturally is through service champions. So service champions are essentially developers who've taken ownership of a product and know how to use it very well. How do you make this happen? Well, devs, we find that having devs part of the design and QA for something that they're going to be consuming, a service that the infrastructure team is coming up with, is really important. That way you have developers perhaps even, and there's an example Greg will talk about later, where they get involved with the process, perhaps even enough to help you build it, and it allows them to take ownership of it and then communicate it to other devs. And what we found is developers, to speak to them properly, you need to be a developer as well. So have your champions communicate the correct way to use a particular service or a feature that you've come up with. And another way is to expose a service. So expose a service to a limited number of developers very early on. We had an interesting problem where we had a lot of clusters, but a centralized logging solution. So from the ops team's perspective, that was the challenge for us. How do we get all the logs from these clusters to Elasticsearch in a secure way where we have authentication on the endpoints and everything? That was the challenge we were addressing. When we saw FluentBit was able to forward logs to Elasticsearch, and we could search them in Kibana, we considered it as job done and handed it over to the devs. All the devs simultaneously found out that the logs were practically unusable. So FluentBit had a field that was being set that conflicted with the field that was coming from their application. So it caused them a bit of pain, and it could have been avoided had we had them involved from the start. So just as every feature has an owner that owns the proper ongoing maintenance of a particular feature, you should also have developers that are the champions for a particular service. Leave it up to them to document and actually propagate the correct knowledge on how to use that particular service, and keep it up to date as well. Cool.
Yeah, it's really important to make sure that your developers are enabled and supported in building infrastructure. If you find through your project you have developers asking a core infrastructure team to build something, and the infrastructure team builds the thing, then hands it over to the developers, and then they start to see problems with it, you need to start reevaluating your ways of working. Broken. Yeah, we had a good success story around this. Fahad alluded to it before. But a team of developers came to us and said, look, we need an RDS database, could you stand it up? And we said, sorry, we don't have a template ready just yet. We don't have the capacity to do it right now. We pointed them towards some documents and a reference template that they could use. And this was for a Terraform module. And they looked at that, went away and built a highly opinionated, zip-specific RDS Terraform module, which included sensible defaults like multi-AZ encryption and multi-region deployment. Once they'd done that, they shipped it over to us, gave us a look. We QA'd it and said, yep, looks good, it's solid, it's robust, satisfies the security requirements, go ahead. From there, they deployed their database. Cool, they weren't satisfied just yet. They then did a showcase. This is a developer team doing a showcase around how they built a reusable infrastructure component. Shared that with the rest of the Zip engineering team. Following from there, I think over the next few days, we had 5 new RDS databases spun up, and all the teams were happy because now they could have their databases, and we were happy that they met the right criteria that we had set. This was a great example of shared ownership of delivery, where the infrastructure specialists are supporting the developers to meet common goals. We talk a bit about two-way value transfer, and this is where By having your infrastructure specialists support the developers to do their thing, everyone really wins. The developers are able to move faster, and we have, well, for one, less work to do, but also satisfaction that the developers are implementing best practice standards and sensible defaults as a common practice. It's also really useful for load leveling, where you're not relying on a single team of specialists to build out your core infrastructure needs. So while we've been busy working on the build out of the infrastructure and getting the developers aligned and supportive and helping us, it's also really important to focus on the developer experience. Spend some time, if you're an infrastructure or an operations guy, spend some time sitting with the developers, become a developer, understand their experience and feel their pain. You don't really know how well the system is working as a whole until you've actually sat with the developer and gone through the how does this actually work. An example here, we heard anecdotally some reports around poor performance or slowness of pipelines, which we kind of didn't take a lot of notice of initially. At some point, we sat down with the developer for some not related reason and said, well, this pipeline's too slow. It was only a few minutes, but it was, when you're running hundreds of deployments per day, it was enough that it was causing a significant problem. And it was big enough that we really needed to get onto it. So once we understood that developer experience, we were able to prioritize it and pretty quickly implement a couple of fixes which improved the overall experience and productivity for the whole engineering team.
Yeah, so I'll just quickly explain what the issue was, because I think we only have a couple of minutes. We were using GitLab CI with Docker executors, and the deployment pattern we were using was three musketeers, so make, Docker Compose, and Docker. And the initial Docker container that spun up on every pipeline run spun up more containers. Now, this led to the containers, without having a shared cache, being downloaded all the time for every pipeline execution. It didn't take a long time, even with an adjacent cache, but it was significant enough to have a slowdown in pipeline. So we switched over to shell executors, where they pulled down and had a shared Docker cache, and that sped up our pipelines by about 300%. So it was a big win for the devs.
And that's one example, but there's a multitude of learning experiences that we can get from sitting with the developer and understanding how they're working. In the same way that product owners go and talk to their customers and find out how their product is working out in the wild and look for opportunities to make it better or provide new services, we need to be treating the infrastructure as a product. Infrastructure is our product and the developers are our customer, so it's really important that we make them happy.
Cool. Scaffolding, templating. So how do you release new features to developers when you have implemented them? With logging and monitoring, it's quite easy. It comes bundled as part of the platform, but how about code and container scanning to pipelines that are being managed by developers? Well, there's a couple of options in this space. We could go with having all the features ready for devs before they even start using the platform. Obviously, that's not possible. And one of the key things about successful delivery is having fast feedback, and you get none of that if you have everything implemented before devs start using it, so not a recommended solution. The other option is to have a way to introduce these features through the use of templates. So GitLab has and include remotes that we could use in this particular scenario. And just quickly on local development, when you're moving into a new space, it's really important to have your developers and both your dev and ops teams get really comfortable with the tooling that they'll be using moving forward. And one of the really easy ways we found this happens is through having the same tools that you're using in production mimicked locally. So we have, and there's no single tool that does all of this for you. So you walk into this with a couple of objectives in mind. You want developers to be able to build, push, and deploy containers to your cluster, whether that's local or remote. You want developers to be able to interactively debug those containers inside running pods. And thirdly, you want to give them some equivalent services which they can use to mimic what's running in production, like Kafka or databases. So the way we did that, or one of the ways we've used that this is possible is through the use of a couple of these tools, specifically Jib, Scaffold, and Minikube. And combining all of these, Jib gives you the Java image, Scaffold continuously deploys it to the cluster, and the cluster is provided through Minikube. And we could find Helm charts that were usable through Kafka has one for, Confluent has one for Kafka, and Bitnami has one for Postgres. So combining all of these, we were able to give devs a really rich local experience that they could test their ideas out in. Cool.
All right, so just summarizing what we've been talking about. The 4 things we figured out are really important to focus on if you're doing this sort of project. Lay the foundation. Try and get as much as reasonable or possible into place before you start placing real workloads on it. Do this off the developer's critical path as much as you can, but get them involved. DevOps inception for every new product project. Try and make sure that your developer and operational and infrastructure and security teams are all aligned and working towards common goals. That leads to shared ownership of delivery, which is, again, around common goals. Make sure that your developers are comfortable working with infrastructure and vice versa. Big focus on the development experience. This is really important. The more developers you have, the more important this becomes. If developers have any pain at all, even if they're not aware of it or don't notice it, it's important that we understand that. We can find opportunities to fix things if we sit down and understand the developer experience and start thinking like a developer.
Cool.
All right.
Thank you.
Thanks, everyone, for coming. I hope you found this useful. While we've got a room full of engineers, I just want to call out, Zip is growing. We intend to keep growing. If you want to get on the train, check out our careers page on zip.co. Find me on LinkedIn. Come and talk to me while we're here. Find a way to get in the door. There's plenty of opportunity there.
And CMD is hiring as well. We've got a booth, so come chat afterwards if you have any questions. Thank you.
Thanks, guys.